let's start the session. Well, good morning, everyone. I hope you enjoyed the keynote and are feeling excited. Uh, we help, we're here to help you keep some of that energy going. Uh, but first, let me introduce ourselves. I'm Akhil, and this is my colleague Eugene. We're both software engineers at Databricks. Uh, Today, we are excited to talk to you about dependency management and Spark Connect. Uh, we've contributed a lot of code to this project in the open source Apache Spark repository and are eager to share our insights with you. Well, before we actually dive into managing dependencies, let's take a step back and look at what dependencies are and how you can benefit from them. Well, the most significant benefit is custom ETL on your data. So many users, including Databricks customers, use custom libraries either made in-house or third-party in their data transformation pipelines. So these libraries allow you to bring custom logic that either typically simplifies a specific problem you're trying to solve or expand the ways in which data can be transformed. Additionally, they allow you to experiment with a lot of open source ML or AI libraries, such as Python's PyTorch. And how you use these dependencies, they're typically through user-defined functions. Now, user-defined function, or UDF for short, are custom functions defined by you, as the name suggests. And these functions run inside the Spark executor, and they work on your data directly. Uh, as with the UDF, you have all of the benefits that the programming language brings you, either Python, Scala, or if you happen to use Rust or Go. This means that you can load your dependencies, packages in and use, say, Pandas, PyTorch, or maybe a custom jar that you built in-house. And you can use this to transform rows of your data and use custom logic. This is useful for sometimes when maybe it's hard to define this in Spark SQL. So it allows you to use the programming language's natural interface to work with the data. And the possibilities are almost limitless because you have access to all of the programming language abilities, meaning you can also access internet in the UDF. Maybe you want to send an API request to one of these LLM APIs, or maybe just an in-house server. And all of this can be done through user-defined functions. So some of you may have already noticed that this is actually possible today in classical Spark. Like, none of what I said is new. It's possible today. You can do this right now, and there's nothing stopping you. But there are some restrictions. So the main thing here is that all of these dependencies are cluster scoped, meaning that if you want to install PyTorch and use it in your pipeline, all the other users of the cluster would also have access to this library. And this introduces the fact that if two users want to use different versions of the same library, then you hit a conflict because maybe one person's code is not compatible with the other person's code because they're using a certain API in the library that's no longer available. So you need to handle these conflicts. Like right now, the way you would do that is to have two separate Spark clusters. Of course, this might not be efficient because you're using extra resources, and this can lead to extra costs. Further, these dependencies are partially static because when you use a certain dependency, you cannot remove it or change its version without restarting the whole Spark cluster. Now, this has latency costs, and restarting a Spark cluster isn't the fastest thing, as some of you may already know. But this changes with Spark Connect. Uh, let's actually look at Spark Connect first and see what it is. It's a decoupled client-server architecture that allows remote connectivity to Spark clusters using the data frame API. So this separation between the client and server mean that you can use Spark and its open ecosystem almost anywhere. It can be embedded in modern applications. You could use them in IDEs, notebooks, and programming languages as well. In the last keynote a year ago, there was a presentation where Martin used Spark Connect from his iPad to connect to a Spark cluster and execute query. So with this like decoupled architecture, it brings a lot of benefits and opens up the ecosystem. And one of the benefits that Spark Connect brings you is dependency isolation. And I'll let my colleague Hyujin talk to you more about this.
Thanks, Akhil. All right, so we identified three problems, right? So the first one is that the cluster scope dependency. So like you add one dependency and then the other users can just use that dependency. The second problem was that the inter-user conflict. So like let's say user A edited like one pandas and then the second user cannot add the different versions of pandas. And then the last problem is that it's statically immutable dependency. So you cannot change, like once you edit, then it's like immutable. All right, so we managed to resolve this problem by implementing the dependency isolation in Spark Connect. So how do we do this? So firstly, we edited the session scoped isolation. So your dependency from the session A will be isolated in the separate location. So you can add whatever the version you want. So suppose that here the session A edit the pandas 2.2.1, and the session B will have a another separate isolated location. So like session B also can install the different version of the pandas. Here, session B install the 1.5.3 and then some other jars. And if you want to like different new environment, then you can just create a new session. Then that will just create another separated isolated place to put the dependencies. So you can manage those dependencies dynamically. All right, so how do we implement the dependency isolation? We implemented the add artifact API that is specific for Spark Connect. And then let me go through how we actually implemented this. All right, so for Python Spark Connect client from Spark 3.5, we edited this API called add artifact. So you can add the like py file or like zip file or the related Python dependency files. So you can add these three files. Unfortunately, it's slightly truncated, but you can add the py files and then like zip file or jar also can be canonical Python package, right? And you can add those files, and then you can add the archive like the tar.gg, and they will be automatically untarred on the current working directory of the UDF execution. So within UDF, you can access those files, and also you can add the arbitrary files. For Scala API, it's from the Spark 3.4. And it's exactly the same. That you just call the same function called add artifact. And for Scala, you can add some jars or the class files that is from canonical like Java or like Scala files. And also you can add the Maven coordinate by using the IV URIs. So it will automatically download the jars to the Spark Connect server, and then it will be distributed to the executor. All right, so let me go through the actual template and examples in Python and Scala. Let me start with the Python first. All right, so this is the typical code templates. It's pretty simple. So just first, you just create the Spark Connect. In my case, I'm connecting to the local host that the Spark Connect server running. And then second, you just upload your files. So you can upload three types of files. The first, arbitrary files, and then you gotta set the file, the parameter to true. And the second, you can add the py files or zip or jars, and they will be automatically added to your Python path. And then last, you can add the archive files, the tar.gg, and then they will be automatically untarred to the current working directory of UDF execution. One good thing is that we now release the Spark preview. So Spark 4.0, you can try. And then one of the cool things in Spark 4.0 is that we now have the pure Python package that's called pyspark.connect. So it will not require any like JVM or anything. It's just pure Python library. So you can try it out later. All right, so let me quickly go through the examples. So I have an example here. On the right side, I have my own module. And here first, I created the Spark Connect session. And second, here I did my own file, the mylib.py, and that has my own calculation logic. Within the UDF, I'm importing my leaf, and then I'm calling my my own calculation logic. And this is the example of the archive. Only one different thing is that you might notice that there's shop and my.dr. And then here I'm specifying the directory that the my.tar file will be untarred. So here in the UDF, I'm listing my current the current working directory. I'm listing the my.dr, right? And then the output will be the list of my files. On the right side is my own tar file, and it will be automatically untarred to the my.dr, and then it will be the return value will be the list of my files. All right. What's next? Actually, you can do more things with the current aid artifact. Suppose that you can pack the current virtual environment, and then you can ship it to the executors. Then you can have a complete different like Python version or a set of other dependencies. But this is not encouraged at this moment because it's a little bit hacky. So we want to make it like better, faster, stronger with the UDF level control. So this is working in progress. So hopefully we can get it for Spark 4.0. But once we do that, then the UDF will be, every UDF will have a isolated execution environment variable environment. All right, that's the for Python example. And then the Akhil will continue with the Scala side.
Right. Thank you, Eugen, for the Python example. Now, a lot of data transformation pipelines are written in Scala as well. And we want to support all of the popular programming languages. And let's go through an example here. So it's quite similar to what Eugen mentioned. The format is almost the same as compared to Python. Now, the only difference is in step number 2, we use something called the class finder. As some of you may know, we have Python and Scala. The execution model is a bit different. Scala generates bytecode, and to allow these UDFs to run in the Spark driver and the Spark executor, this bytecode has to reach the executor. And what step number 2 does, it sets up this automatic loop that automatically uploads all of these class files, all of this bytecode onto your executor that would allow your UDF to run. And all of the other steps are basically the same as Python. You still do add artifact via jars, or you can use an IV URI. Let's look at an actual setup. So this would look like a project. You would see that we're using the 4.00 preview version, which has IV support. So the first 2 library dependencies are for Spark Connect, and the third one, it's a library, a third-party library that we are going to use in our example to generate random strings. So this is the sample code. This is you could copy paste this code and put in a project, and it will run as it is. Now we'll go through the steps. The first one is setting up the session. Not much of a change in the API compared to Python, still the same. Now this one is where it gets a little bit tricky because we need to transfer the bytecode over programmatically. What this piece of code lets you do is it finds location where your bytecode is generated. It registers that folder with this class finder, and then it registers it with the Spark execution model such that everything is uploaded every time you use UDFs. And now this is a third-party library on the Apache to an Apache IV URI mode, and we want to add this to our executors and the driver, and we want to use this in our UDFs. So this sample UDF does something super simple. All it does, it takes in integer value, and it concatenates with the random string generated from our custom library. Now, note that this custom library was not added to the Spark cluster at the time of boot up. It was added when the spark.add artifact API was called. Next, when we actually run the UDF, you can see that the output on the right side, the random strings are generated, meaning that our custom library was in fact used in a UDF. Now, we use a simple library as an example, but as I mentioned before, it's almost limitless in what you can do. You could have custom clients, you could use ML libraries, any sort of library that helps you transform your data in the way you want it to. Now, for this demo, we have a recorded video. Let me try playing it. Yeah, here on the right, we are starting up a Spark Connect server. Uh, this is all done locally. It's booted up on localhost. The text is not that important. It just means the Spark Connect server is up and running. On the left, we did a pip install PySpark Connect. This is a virtual environment where no libraries have been installed before, so this is all fresh. Pip install PySpark Connects sets up everything for you, and now you are running your Python REPL. And the text is a bit truncated at the end, but what we're doing right now is we're trying to set up the Spark Connect session. I'm just waiting for the text to go up a little bit. Yeah, what we did right here is we set up the Spark session to connect to our cluster that's also running locally. And we did a simple spark.range1 just to show that the session is connected to the cluster. And you saw that the cluster logs did in fact reflect that. And now we start defining a UDF. It's a simple one. We have a file called hello.py that we've built locally. And this UDF simply imports this file and it calls in a function defined in this file and returns the input. So in the text below, which is slightly hidden by the captions, we are adding the artifact. The artifact was copied over to our cluster, and then we execute the UDF. Let me skip the ending there. Basically, what we did was we printed an ASCII art image of a hand. And this was just a little fun example, just showing you what capabilities are possible. The library could be, again, it's fully custom. You can do what you want it to do. And the best part is this is all compatible with Databricks. So if you are a Databricks customer and you want to do something similar in our environment, it's possible. And we have something called Databricks Connect. It's simply a wrapper of over Spark Connect on the OSS side with some Databricks magic put on top. This means that you can leverage the full power of the Lakehouse platform with the Spark Connect model going via Databricks Connect. And the code is almost plug and play. So when you do use OSS and you want to move to a Databricks Connect model, not much changes. It's only when you set up the Spark session, you instead use a profile to point to a specific cluster and a workspace in your Databricks deployment. And similarly for Python, it's almost the same. The only thing is the set profile differs, but everything else is the same for the most part. We do give you something called the add compiled artifact, so you don't have to register a class finder automatically. This makes it a little bit simpler, but it's almost the same with just changing one line and everything works as it is. Now, if you would like to know more about Spark Connect or Databricks Connect or just Spark in general, there's a couple of sessions that are upcoming. The one that is on 13 June, 12:30 p.m. Leverages Databricks Connect with Databricks products such as Serverless Spark. And also, Spark Connect is in 3.5 and 4.0. So if you would like to know more about Spark Connect and the additional features that it may bring, make sure to check those talks out as well. Thank you.